Everybody is taking data and information at the moment. It doesn't matter who it is, but we don't know, we don't recognize that anymore because we don't look on the track. So this is very important, or for this reason it's very important sometimes to step back from the simulation and go into track to see how do they really perform.
The core idea for the next years must be to merge the different data sources together. That's it.
And it would be really interesting for us as an operator to have sensors also applied on these old switches. Now coming back to major switch inspection itself, I brought you with these slides the typical defects which we find in the major track. This is first of all cracking or wear at the switch plate as well as at the stock rail, and very important for the risk against derailment is a gap between the switch plate and the stock rail, which has to be monitored carefully in order to guarantee the safety. Another typical defect which is found are Rcf defects, which occur at the switch plate and at the closure rails itself. Another defect which we often find is contact between the wheel flange and the check rail itself. This leads to friction, this leads to lateral forces on the check rail itself, and leads to bad ride quality when passing over the major switch. And the fourth error, or the fourth defect, also very important, is wear or REN fractures of the crossing nose and the wing rail itself. In order to give you some images how this looks like, I brought you some photographies from our track. On the top left, you can find a fracture of the crossing nose on the left. This happened at the double diamond crossing at the depot, not on the passenger track, fortunately, but nevertheless, we had to introduce a speed limit, which is necessary when finding this kind of defect. On the top right, you can find the gap between the stock rail and the switch blade itself. On this photo here, it's not very big, but it is interesting, or it would be interesting to know how this gap varies within time of the year and how it acts due to temperature-induced stress on the switch blade. The photo on the left below shows you the check rail and contact on the check rail. We sprayed color upon the check rail in order to derive the first point of contact. And the closer this first point of contact comes to the very entrance of the check rail, the more dangerous it can get. And if it's too close, you also have to introduce a speed limit on this switch. And the fourth photo on the bottom right shows you Rcf defects. I would call them spalling, not head checks, but spalling, which were maybe introduced or caused by the excessive use of lubrication or the lubrication device itself.
Of course, we do care about the health of your railway assets as you guys do.
It's to clarify about data ownership, who's the owner of the data and who wants to give it, and data security.
voestalpine, one step ahead.